Okay, next bit we're looking at section formula. So just looking at this in terms of what we could have done from that 5. So we've got A is the point 2, 0, negative 1, and B is the point 2, negative 4, 3. We've got to find the coordinates of P on AB such that AP to PB is 3 to 1. Or it could have been written AP over PB is 3 to 1 like that. So we sketch what's going on. So this one's length is 3 compared to this one's length is 1. So altogether the total length is 4, which is useful to know. We're going to use that a couple of times. So this is the long way of doing it. So we know A to B, so it's B minus A, 1 you're going to minus the 1 you've come from. We write our 2 points as position vectors and we get AB. We now know that AP is 3/4. If we look at our diagram, it's 3 out of the 4 all the way along. So it's 3/4 of AB. So we do 3/4 of the point we've just, or the vector we've just worked out. So we get 0, negative 3, 3. We know that AP is P minus A, 1 you go into minus the 1 you've come from. The only one we don't know is P, the position vector of P. So AP plus the position vector of A should give us a position vector of P. So we do it that way. We get our position vector of P and then we turn it down to get P, the point 2, negative 3, 2. Now, a quicker way of doing it is using section formula. Now, section formula, the position vector P of any vector here is NA plus MB over N plus M. Now, this is for P dividing AB in the ratio M to N. So you'll notice that the N goes with the first one and the M goes with the second one. So what we're looking at is we're basically putting it the other way. The way I tend to do it is I write my 2 coordinates, it's splitting the ratio, and then do the arrows knowing that one's going to that one and that one's going to that one. So what we do is we do 1 times the position vector of A plus 3 times the position vector of B, and on the bottom M and N are 3 and 1, so 3 add 1 is 4. So we work out the 2 of them multiplying in, we then add them, and rather than writing the 4 on the bottom, we can write 1/4 of 8, negative 12, 8, which is 2, negative 3, 2. When we turn it down, the point is 2, negative 3, 2, as we got up here. Much quicker method, and once you get into it, it's far quicker than this one. So let's look at a trickier example. So, wee bit of waffle. So an aircraft is flying at a constant speed in a straight flight path. It takes 3 minutes to fly from P to Q and 2 minutes to fly from Q to R. Relative to suitable axes, P is the point 3, negative 6, 12, and Q is the point 6, 0, 3. Find the coordinates of R. So again, we do our wee diagram. This one's 3 compared to this length of 2. So we know that PQ to QR is 3 to 2, but we need R to be the middle of our journey. So we need to go P to R, then R to Q. Yep, the last one we went P to the middle to the end. So we need to go to the middle to the end. So we actually, our journey is P to R, then R to Q. So P to R is 5, and then R to Q, because we're going the wrong way down the vector, is negative 2. You're probably not going to get one this difficult, but I'm just showing you the middle one. If you're asked to find the point in the middle, you have to do the journey to make the one in the middle. We needed R to be the middle, so we went P to R, then R to Q. So once we've got our ratio, it's pretty straightforward. We write our PQ, the 2 endpoints. We write our ratio 5 to negative 2. We do our arrows. So negative 2 times the position vector of P, 5 times the position vector of Q. We add them. And M and N, 5 plus negative 2 is 3. So negative 2 times that, negative 5 times that. So it's a third off once we add these two. So we get 8, 4, negative 3, which we turn down to be the coordinates of R are 8, 4, negative 3.